we're going to look at one of the other dimensions of singularity type thought, which merges into the other super topic of futurism, the search for extraterrestrial intelligence. Now, I have other videos on this channel discussing aspects of both of these subjects, sometimes together, but I want to take us back to an article I wrote way back in May of 2009. So almost 14 years ago. I wrote this article called SETI and the Singularity because I noticed that most search for extraterrestrial intelligence thought did not account for the accelerating rate of change, and people in the singularitarian community had more advanced ideas in terms of how the accelerating rate of change and artificial intelligence have implications for extraterrestrial life and how the number of civilizations in our galaxy might be very different than the SETI crowd thinks. Now, I've done a read-through of this entire article, which you can watch in this video up here in this upper right-hand corner link. Now, recognize that this article was written in May of 2009. But in summary, this article describes 4 postulates that I have here in blue. The expected lifespan of an intelligent civilization is rising. Telescopic power is rising quickly, possibly at 26% a year. That rate is slower now, for a reason I'll talk about in a minute. Thousands of planets in the life zone will be confirmed by 2025. A civilization slightly more advanced than us will soon be easy for us to detect. So in the article I give rationales for all 4 of these postulates. Now in combining those 4, back in 2009, I came up with this boxed text as a prediction. If we do not find any evidence of extraterrestrial intelligence by 2030, then we can confirm with some certainty that such civilizations are not as common as the proponents had hoped. Additionally, each subsequent year without a discovery makes the probability exponentially less likely. The crux of this is that the exponential rise in computational power was increasing telescopic power in tandem, and I speak about that in this video up here in the upper right-hand corner. And that means that the amount of search we can conduct is rising exponentially, and we can do more search per year now than we can do in the entirety of the 1900 to 1980 period, 80 years for example. So we can do more in 1 year now than we could do in 80 years at that time. But computational power is also saturating, and I think it's saturating temporarily, but let's look at that for the next concept of importance over here. This chart is from the video that I have linked up here in the upper right hand corner about how much computational power is needed for a technological singularity, and that is somewhat related to the computational power needed to search for extraterrestrial intelligence over the entire galaxy, coincidentally enough. Now in the SETI and the Singularity article that we were just at, I said 2030, but of course in 2009 I didn't think that computational power would deviate away from this trend line, and I thought by 2030 we would be over here. I still think we are going to revert back to this trend line because this is a trend line that is established by centuries upon centuries of data, even if the way computation is measured is going to change and may not be in this exaflops, teraflops measurement metric anymore. We're still going to revert back to this trend line, but if we don't, then the 2030 number that I thought would be here might only be over here, so about 100x difference. Now if it's 100x difference, then the number of exoplanets is going to be a lot fewer than it was going to be in the old trend line. How many exoplanets have we found to date? Well, in that SETI and the Singularity article, in May 2009, we had discovered 347 to date. But in 2022, we crossed the 5,000 exoplanet measure, which I speak about in detail in this video up here. 5,000 exoplanets because it is an exact function of the exponential rise in computing power. So if we revert back to this trend line by 2030, the 5,000 will very quickly get to 50,000, 100,000 even. And that is effectively the number that I consider a large enough sample size under which we might be able to judge whether there is some evidence of an extraterrestrial intelligence, at least in the nearby star systems. There's still a very, very small fraction of the entire galaxy, maybe only 1/1,000,000th of the entire galaxy, but still it is a large enough sample size to get some awareness of the density of such civilizations, and the pool of data will not be large enough until we have that much of a sample size. That's why in the 2020s at the moment we still cannot conclusively say either way. It is noteworthy though, however, that when Frank Drake created that equation and the Fermi paradox was discussed even earlier than that, and Carl Sagan described the Drake equation in great detail in his 1980 Cosmos series, we had no evidence whatsoever of extraterrestrial intelligence. Fine, we had examined very little of the galaxy by that point. Now, as of 2023, we have examined a fair bit more. Still a very small fraction, but we have examined much, much more because we have 5,000 exoplanets that we have confirmed now, whereas at the time of Carl Sagan's Cosmos, there were none. The very first exoplanets were only confirmed in the mid-1990s, and even then it was one at a time. There was sometimes an entire year without a subsequent exoplanet discovery until it began to rise exponentially. Now they're being confirmed at the rate of dozens or even hundreds at a time, and that number will also continue to rise. But despite all that, there is no evidence at all of extraterrestrial intelligence. Absolutely nothing relative to 1980 or 1960 or 1950 to lead us to believe that there is extraterrestrial intelligence somewhat nearby. Pretty soon, that's why I chose that 2030 year, if we don't find something by that time, and I mean this 2030 at the trendline level, not the suboptimal 2030, then you have to begin to wonder about, well, maybe extraterrestrial intelligence is not nearly as common as some people would like to believe, or fictional franchises like Star Trek have depicted. Now let's look at that for a second as a sidebar. Now Star Trek is fiction, of course. I have to point that out strenuously because there's always some small-minded imbecile who points out, well, he talked about Star Trek, therefore everything has to be ignored. That's just crazy. They get hysterical the minute you even mention that within the context of any serious subject. Yes, it's fiction. However, I am going to show you why it's worth talking about over here. In the Star Trek version of our galaxy, intelligent civilizations are very common, and they exist every 10 to 15 light years in every direction. Every 10 to 15 light years in any direction, there is an intelligent species that is capable of interstellar travel. For example, this is the Sun, Sol, S-O-L, and the three other species that formed the United Federation of Planets in the beginning were all less than 20 light years from Earth. The Tellarites were from 61 Cygni, which is 11 light years from Earth. The Andorians were from Procyon, which is also 11 light years from Earth. And the Vulcans were from 40 Eridani, which is 16 light years from Earth. So you have three civilizations that are no more than 16 light years from Earth and are near each other and associated with stars that exist in our real galaxy. These are actual stars that exist, and these fictional races were assigned to those stars. Now, at the time of most Star Trek content creation, which was 1966 to 2005, let's say, as all of the worthwhile material of the series, even if you give a very generous bar of what is considered worthwhile or not, at that time you could not disprove that there might be intelligent civilizations at this density in our immediate vicinity among stars of suitable type. That's why there are three that are nearby, and these three joined up with humans to be the first four societies to form that United Federation of Planets. Within a matter of years, not decades, but years, if not 2030, shortly thereafter, we will be able to ascertain that intelligent societies are not this common in our galaxy, because by that point it will be impossible to not detect all these civilizations if there is one every 10 or 15 light years in every direction. Star Trek has assumed a certain density of intelligent life that is so far not on the track of being proven. Again, it's too early to conclude that, but the trend is going in the direction, and I will not be surprised if by 2030, 2035, we have still found no evidence of anything at all. Certainly not the Star Trek density. To give an idea of how much density there is in Star Trek, this is a book called Star Trek Star Charts that I purchased a long time ago. This is the vicinity of the entire United Federation of Planets and where most of the episodes of most of the TV shows take place, with the exception of Star Trek Voyager, which is in another quadrant. Sol is Sun, and then all those other nearby civilizations I mentioned over here. And these are the boundaries of the Federation and other rival empires like the Romulan Star Empire and so forth. So various episodes are associated with planets and stars that are depicted on this map. And each ring is at a 10 light year radius. So even within 50 light years of Earth, there are a huge number of inhabited planets and a variety of species that exist. It's safe to say this type of density of intelligence is something we will find to not be the case. That is the direction that the absence of discovery in the face of exponential computing power and exponential telescopic power rise is taking us to. So now coming back to this, we will find out over the course of the next several years, and especially the next several decades, whether there is in fact intelligent life within a certain radius of space from us. And as we get further and further, we will be able to peer deeper and deeper into the galaxy. We should not be entirely surprised to find that we are one of the most advanced in our galaxy. Again, it's way too soon to assume something like that, but that could be what we discover based on the complete absence of evidence so far. And by 2030, that side of the debate gains more strength because of the exponential rise in computing power. How many exoplanets do you think we should have to discover before we can say that intelligent life isn't as common as we might have thought? 100,000 exoplanets, 1,000,000 exoplanets. And remember, as our own technological civilization lasts longer and longer, it occupies a greater percentage of our entire planet's existence, which is also part of the Drake equation. So not only is exponential computing power crowding out the possibility that there's many, many civilizations that we have not yet discovered, but our own continued existence means that the pitfall of a civilization wiping itself out also becomes less and less frequent. So this concept of a Fermi paradox becomes somewhat more easily explained. It is possible that we are among the first, if not the first, one of the first few in our galaxy. There may be many that are less advanced than us, but pretty soon it will be harder and harder to say that there are many that are more advanced than us, because it will just be impossible to not detect them. And again, I'm only talking about our galaxy. Different galaxies are a different matter. Traveling between stars versus traveling between galaxies is just as large of a leap as the difference between traveling between planets versus traveling between stars. A galaxy is a much, much further leap. Even in Star Trek, they travel between stars very easily, as though it's something they do all the time, but they are not able to travel to another galaxy or even remotely consider a voyage of that distance, for some perspective about how large that distance is. So different galaxy is another matter, but maybe each galaxy is just a laboratory for 1 or 2 or 3 civilizations to see what happens. These are things we don't know, and these are all speculative futures. But as exponential computing power rises and the duration of our own civilization increases and artificial intelligence on Earth advances more and more, which is also a dimension of interstellar exploration and a search for extraterrestrial intelligence, the absence of any evidence of extraterrestrial intelligence is starting to crowd out the belief that maybe there are a large number of intelligent civilizations and there are thousands or even millions in our galaxy itself. There might be very few for all we know, and somebody has to be first. We might find out that we were the first. So just some food for thought, something to ponder. I urge everyone to read that SETI and the Singularity article, despite how long ago it was written. And if you like this type of content, I encourage you to subscribe to this channel. Thank you very much for watching.